So when we look at the cosine function is going to look like this. So we start at 0 degrees. Okay, we have a cosine ratio of 1, so the x-coordinate is 1. And as we go to 90 degrees, the x-coordinate goes to 0. From 90 to 180 degrees, it's in quadrant 2, so we're going to have negative x-coordinates. From 180 to 270 degrees, it's going to be in quadrant 3, so it's going to have negative x-coordinates, but it's going to come back to 0. And then from 270 to 360 degrees, it's going to go back to an x-coordinate of 1. Okay, so this angle will be 90 degrees here. Or sorry, that's not 90. That's going to be 360 degrees here. Okay, so in order to make this into the inverse into a function, well, if we switch to x and y's, we're going to have our cosine function just going to keep on going. Does not pass the vertical line test. So we need to trim this function. And we trim this function by using only this part here, and which allows us to have outputs between 0 and 180 degrees. Okay, so this pi represents 180 degrees. Pi over 2 represents 90 degrees here. Okay, so this now becomes a function by trimming it. Now, if you recall, our cosine, the inverse cosine on our calculator only gives us angles. The theta 1 values are only between 0 and 180 degrees. And again, the reason why is because the arc cos is actually a function. Okay, so in order to keep it a function, we need to keep it in these two quadrants. So we trim the function, which makes this actual function. We can now treat it as a function. So the inverse of cosine then is going to be, well, my output of ratio becomes my input for the arc cos, and my input angle for cosine becomes my output for the arc cos. Okay, so this is going to undo the cosine, which is our inverse cosine, and our inverse cosine graph looks like this. So this is my y equals the arc cos of x. Okay, so my input is going to be my ratios from -1 to 1. The output is going to be the angles from 0 to 180 degrees. So that's what my domain and range look like. And again, this arc cos is in fact a function. Your calculator understands it as a function. It only gives you one angle when your input is a ratio. Okay, now the other angles are these ones here, these angles that appear beyond this period here, or half period in this case, and we use the symmetry of the circle to find those coordinates or those points, but the actual function gives us theta 1, and it only gives us theta 1 in those two quadrants. So when we look at tan, this is our tangent function. So if we look at -90 degrees, this is positive 90 degrees. At -90 degrees, the slope of our graph at -90 degrees is vertical. Okay, and so we get a vertical asymptote at -90. At 90 degrees, the slope of the graph is going to be vertical again. So again, we have our asymptotes at -90 and positive 90 because their slopes are going to be infinite on those points. But what happens is in quadrant 2, as I go from -90 to 0 degrees, my slope is going to decrease all the way to 0. Oops. At 0 degrees, my slope is 0, and as I go through quadrant 1, my slope is going to be positive. So it looks like this. My slope is infinitely negative, goes all the way to a slope of 0, and the slope becomes infinitely positive. Okay, so that's what the tangent function looks like. If I want to do the arctan, we just turn it on its side essentially. We switch our x and y, so that's 90 degrees and -90 degrees here. And we're only going to look at one period of this. Okay, because if I look at more than one period, again, we're talking about theta 1 and theta 2, and it makes this a non-function. So we have to trim this function as well to keep it a function. Okay, so it passes a vertical line test. So my input is going to be my ratio, and my ratio can be, my slope could be negative infinity all the way to positive infinity, and the output is going to be my angles between negative 90 and 90. So my tangent, my arctan, has a range that's the same as sine, okay, except it does not include the endpoints of 90 degrees. Okay, so we just make sure we put an open circle at 90 degrees and negative 90 degrees because we can't have slopes at that point. But again, my input is my ratio or my slope. The output is are my angles from negative 90 to 90. So when we look at the inverse tan, this is my tan ratio. The input is my angle, output is the slope ratio. So if I use arctan, I can rewrite it with arctan. That input is my ratio or slope. The output becomes the angle, and because arctan is a function, we restrict the output to these two quadrants, and that's what your calculator gives you when you use arctan on your calculator, and then we have to infer the angle on the other side of the circle to be able to get the theta 2 value when we undo tan. So basically the domain of the function, or the ratio slope that we can input, is from negative infinity to infinity. The output is going to be angles from negative 90 to 90, not including the endpoints. So when we use our interval notation, we use a curved brackets to indicate that we don't include the endpoints as part of the interval. Okay, so this is a tangent as a function. We don't arctan as a function, and arccos as a function, and arcsine as a function. Okay, now we don't need to know the graphs of these. We will later on, but we don't need to know the graphs of these right now. We just need to understand this idea that we can treat it as a function, and that this function is undoing, or the inverse, where our inputs and outputs switch when we look at the arctan function. Okay, not just the arctan function, but all the inverse sine, inverse tan, inverse cosine functions.